Today we are going to do one of my all-time favorite lessons in geometry, which is about parallel lines cut by a transversal. This is module 21, and it's all about, you're right, Drew? Yes. It's all about the angle relationships that we can find between parallel lines and in triangles. This is super, super important for after you're done with algebra. You're not going to be using it too much during algebra, but once you get into high school and you're doing geometry, it's going to be expected that you know this also. This is sometimes on the co-op. So, to begin, parallel lines and transversals. Let's make sure that we understand what we're talking about before we get into all this stuff. We already know parallel lines are two lines that are the same exact distance away from each other, and so they will never, ever, ever intersect. A transversal is a line that intersects two other lines in the same plane at two different points. Now, it doesn't have to be parallel in order for this to be a transversal, but the relationships that we're going to discuss today only exist between parallel lines that are cut by a transversal. So, what this looks like is two parallel lines. This is A and B, and T is the transversal. So what happens are if you have these two parallel lines and they get crossed over by this transversal line T, a whole bunch of angles are formed and they have special relationships. And we can actually find every single measure of all of these angles super easily. So we have to learn about what kind of relationships these are. So you have a nice convenient chart here to help you, and I also included a chart for you on today's agenda. So the first thing we have to do is discuss what these words mean. There are different types of angles that are formed. The first type of angle is called corresponding angles. So I put a little key down here to help you. Corresponding, you want to think of them being on the same side. So corresponding angles would be something like angle 1 here and angle 5. They're on the same side and in the same spot. So as you can see, angle 1 and angle 3, they're on the same side too, but they're not on the same spot. You can imagine taking angle 1 and moving it down here and it completely overlapping. So angle 1 and angle 5 are corresponding angles, and what we know about them is that they are congruent, so they're equal. Now on the other side, we also have more corresponding angles. We have angle 2 and angle 6. And those are also corresponding angles. They're equal. Okay? Similarly, angle 3 and angle 7 are corresponding, as well as 4 and 8. Then we have the word alternate. When you see the word alternate in any of these names, it means that they're on the opposite side. So the first one we have are alternate interior angles. So interior is referring to inside the two parallel lines. So alternate interior means that they're inside and they're on opposite sides. Alternate interior angles are equal. They make a Z shape like this. Okay, so the alternate interior angles here would be 3 and 6 and 4 and 5. Okay, and they are also congruent. Alternate interior angles are congruent. Next, we have alternate exterior. So the exterior is out here and out here. So alternate meaning on the opposite sides, they're also equal. So we have angle 2 is on the exterior, and on the opposite side would be angle 7. And angle 1 and angle 8 are alternate exterior angles. And they're also congruent. So far we know that corresponding angles are congruent, alternate interior angles are congruent, and alternate exterior angles are congruent. And there's, interior inside, exterior outside. And when I say inside and outside, I am referring to this. This is interior, and these are the exterior. Okay? Anyway, same side interior angles are the ones that are inside, but they're right next to each other on the same side. So like 3 and 5, and then 4 and 6. They are the only types of angles that we're defining here that are not congruent. They are supplementary. My Y got cut off here. They're supplementary. And if you recall, supplementary means that they add up to 180 degrees. Okay? So this is probably very confusing just throwing it at you. So I'm going to show you what I mean. But first I wanted to show you the nice chart that I have here for you guys. And I also included it on the agenda. So if you wanted to print it out, an extra copy or whatever you want to do with it, you can. Okay, so first it has the transversal. It's telling you what the transversal is, right? Next, it's giving you corresponding angles. There are 2 angles that lie on the same side of the transversal in the corresponding positions. So the dots are referring to an example of what that looks like. And they're not the only one, they're just an example. Alternate interior angles, remember it's inside, so you want to look for like the Z shape. And the ones that are opposite of each other are the alternate interior angles, and they're equal. Alternate exterior angles, they're outside the transversal on the opposite sides. They're also equal. And then supplementary angles, they can be anywhere. So any place that you see a straight line, they add up to 180 degrees. We know that already. And we also know about vertical angles. They're the ones that form an X and they're opposite. They are equal. And finally, the consecutive interior angles or corresponding interior, what did we say before? Not corresponding. I'm so sorry. Same side interior or consecutive interior. It's used interchangeably. That means they're both they're interior, but they're not opposite sides. They're on the same sides, these two, and they add up to 180. Okay? So let's put this into action so that you can see what is actually happening here, so you're not too confused. Okay. So when you have 2 parallel lines cut by a transversal, we have 8 different angles, okay? And if we know just one of those angles, we can find every single other angle in the entire thing, okay? So in this example, they want us to find angle 2 when we know that angle 7 is 125. So the first thing that you do is you label what you have. And then what you want to look and see is, do the 2 angles that you're looking at have a relationship? So inside here, these are the interiors, and then these are the exteriors. So what you should notice is that angle 2 and angle 7 are alternate exterior angles. Okay, and that means they're equal. So if measure of angle 7 is 125 degrees, then that means angle 2 is also 125 degrees because they are congruent. Okay? Now, this is not part of the problem, but I want to show you how we can find every other angle in this whole diagram. First thing that we know, whatever stands out to you first. I know that vertical angles are congruent, so that means angle 3 is also 125 degrees. I also am noticing that this is a straight line here. They're supplementary. So I know that 125 plus this angle 1 is going to give me 180. So I have to figure out how many degrees are left here to get to 180. So that would be 55 degrees. Right? So now, if I know that this is 55, then vertical angles tell me that angle 4 is equal to that, which is also 55. And now, looking at my alternate interior angles, that kind of a Z shape, I know that the opposites, 3 and 6, are equal. So if 3 is 125, so is 6. And 4 and 5 are alternate interior angles. So if 4 is 55, 5 is 55, which leaves my last angle, a vertical angle, which is 55 degrees because they're all equal. So what you notice is that even though there are 8 angles there, every single angle in a diagram that has 2 parallel lines cut by a transversal have one of 2 measurements. They're all equal to either 125 or 55. And in every single one that you do, they will always have one of two measures. Isn't that cool? So now let's bring it into the algebra world a little bit, where we have to deal with, this is one thing, this is taking it up a notch, okay? So we're going to deal with the relationships that we know and then bring it into finding the x value. So first things first, we are going to look at what we're given. They want us to find the measure of angle VWZ. So VWZ. We are looking for that. That is our goal. Angle VWZ is what we're trying to find. So you want to look at what you're given, see if you can figure out that relationship. So I notice that both angles are inside the parallel lines. So that means that these two angles are either same side interior or consecutive interior, whatever you want to call them. And I know that that means they add up to 180. So what I can do is I can take these two and add them together. 6x plus 3x, I know is going to give me 180 degrees. And now I'm going to solve this equation to find x. So combining like terms, I have 9x is equal to 180. And then I divide by 9 on both sides. And x is equal to 20. That's not what I was supposed to find, though. I was supposed to find the measure of angle VWZ. So angle VWZ was given by 3x, right? So angle VWZ is 3x. So to find it, I just plug in 20 for x. So 3 times 20, that gives me 60. So angle VWZ is equal to 60 degrees. That's it, okay? So I'm gonna have you guys do the your turn. Pause, give it a shot, and unpause to check your answers. Remember, when you're starting out, you always want to look at what it is you're trying to find and then look at what else is given and try to see if the two that you're looking at have a relationship or not, okay? So go ahead and pause and then unpause to check your answers. Okay, so if you look at the angle you're trying to find for the first one, which is GDE, that's here, and you are comparing it to this angle here, which these two don't have a relationship. But what you do notice is that these are vertical angles. So that means E is equal to 6x. So that means these are same side interiors. So if you add them together, they should equal 180 degrees. So what I did was set them equal to 180, solved and got 18, and then I was able to find angle GDE by replacing x with 18, and I got it with 72. Then they wanted us to find BEF, which was 6x. So I could either just plug in 18 for x, or I could do 180 minus 72, which gives me 108. And then finally they wanted to know CDG, and I noticed that they are alternate exterior angles, which means they're equal, so I didn't have to do any work. I just said that it was 108. Okay, I did include a few extra problems for us to try. So I'm going to quickly go through it, and then you guys can try the last ones on your own. So U, V, Y, and blank are a pair of corresponding angles. What would be a pair of corresponding angles? It has to be on the same side in the same spot. So that would be here. So that would be VWZ. Okay. Then angle WVY and VWT are what kind of angles? I'm going to erase the other ones that I'm not using now so that we could see. Wait, sorry, hold on. Let me start over. Let's just erase this so I can see clear. Okay, so W, V, Y, and V, SWT are what kind of angles? So they're inside, they make that Z shape. That's alternate interior angles. Sorry, my stepson is really into Fortnite. Now we're going to find the measure of angle SVW. So SVW is here. Okay? In order to find this, the only thing that I know is 5x and 4x. And again, these are same side interiors. So to find this, I have to add them up and set them equal to 180. 5x plus 4x is equal to 180. 9x is equal to 180. If I divide both sides by 9, I can see that x is equal to 20. So SVW is 4x. So that's 4 times 20, which is 80 degrees. So SVW is 80. Then we need to find VWT, which is the 5x. I don't even need to plug it in again because I know if this one's 80, the other one's got to be 100 because they have to add up to 180. Nice and easy. Okay. So now we're going to do these ones. I want you guys to do these ones on your own. So pause and try it and then come back to check. Okay, so here are the answers. All the pairs of corresponding angles. So you were looking at the ones that are in the same spot. So we've got angle 7 and angle 3, angle 5 and angle 1, angle 8 and 4, and angle 6 and 2. So if this is confusing to you, all you need to do is just turn it this way to see it. Alternate exterior angles, we have 7 and 2.